This is the WattDepot Optima benchmarking project. I'm Jordan.
I'm Keone.
And I'm Greg.
Okay.
So first we'll talk a little bit about the background of our project. So our project is based around WattDepot, which is an open source web service that collects and stores data from smart meters. WattDepot was developed locally here at UH by the Collaborative Software Development Laboratory in the iScience department. And one of the nice things about WattDepot is that it provides a RESTful API. So not only can you collect and store data, but you can access it and do all kinds of interpolation and aggregation on the data. So WattDepot is going to act as what is going to allow us to develop new applications for the smart grid, and hopefully this will be the magic touch to make everything in the smart grid work. So the motivation for our project is that while WattDepot is great, no one's really done any stability or performance testing on it. So our project is going to try and take this on. So here we have a graph. This is generated by our program, and interestingly, we actually had problems in development, and our program helped us develop our own program. So it's already paying off.
Okay, so the goal of our project was as you saw on the previous slide, you saw those arrays. We want to create a benchmark tool that displays it for users as well as for developers. So first goal, create a benchmark tool that measures the requests that are handled per minute, as well as measure like error rates that may occur when running WattDepot. And ultimately, we like to visualize those results once those the benchmarks are run. And then we would want our benchmark tool to be extensible, meaning if developers would want to create additional features on what they would want to benchmark in WattDepot, they can do that. And here's what we've done this semester. So currently, WattDepot Optima easily allows you to conduct benchmarking of WattDepot's REST API. Easily allows you to choose what you want to benchmark. For example, if you're a user wanting to retrieve data or store data, you can conduct benchmarks on that. If you want to do puts on the database or do gets on the database, you can. All you need to do is fill in a config XML file with your parameters, and you can choose. We have a set amount of test cases, and users can choose what they want to benchmark specifically. And once those benchmarks are run, the results are displayed graphically in a file for you to look at.
Okay, so we'll be running it from Eclipse right now. The config file it's just a basic XML. Each test will have its thing. There's a list of the different APIs or API calls that we've implemented on our wiki. You can choose various things like the range of threads to do, how long you want the tests to run. Everything has like a default, so if you don't add in this time to live, it would just run for a default of I think 10 seconds. But then you can modify it yourself. So once you have this all set up, you can just run the parser, and it'll begin doing your tests. Once the tests are finished, in a little bit. So these are really short tests. They're only about 5 seconds. So it's just more of a demonstration. But then afterwards, they'll be put into this benchmark folder, where each test will get on a separate folder, and then results are put in text files and in graphs. So for an individual test of say 100 threads, it'll graph it based on time versus how many successful hits it has. This one is for the health check, which is basically just pinging. And then if you run multiple number of threads, then it will aggregate the results and show you a graph based on number of threads. So then you can see here, like, the more thread, for a while it's all good, but once you start putting in more threads, requests start going down due to overhead. And then after these are all done, it goes in, yeah. So here, yeah, so these are two different things that are useful in different ways. If you want to just look at like successes per time, that's one thing, but often you'll want to be interested in how it'll do when you have more and more threads to see how WattDepot will scale, and it can show that as well. Okay, so on our wiki, we have it's stored on it's hosted on GitHub. We have the basic introduction, about, installations, and then all the code is up here as well. And it's all stored in the API for the Java docs. So one of the most interesting things I think was the enum class.
So we implemented our benchmarks as Java enums, and one of the nice things about this is that we were able to use, we were able to create like procedural benchmarks. So these are all benchmarks that have specific names, but they're all part of the same enum class. And each enum has these two methods called execute and setup. So at the beginning of our test, we would call setup to perform any necessary setup for our benchmark test, like if we were creating sources or users so that we could run our benchmarks. And then we can procedurally call execute on any benchmark, and it would run. Another nice thing is that because we're using XML for our config file, any values that are stored in the XML, even if they're not recognized by the system, get passed into the system. So if a user wanted to develop a new benchmark and they wanted to add a new parameter, they could just add it into the XML, and it would get passed into the setup method via this hash table. And as you can see, this setup function returns another object array, which in turn gets passed to the execute function. So if there's a method, if there's a variable or a method or a reference that you needed in the execute method, you could just pass it into the XML and you would get it here. So it's very nice and scalable, and it allows developers to easily implement new tests. So jumping back to our wiki, actually, I'm gonna drag. If we jump to the pages, here's our home page, a little bit about our tool and the status of our project. Installation. So we have a nice installation guide too. Okay. So we have installation instructions. We're using the Maven build tool. Also, we provide an executable jar. We also provide documentation to the WattDepot server, which we're using. We provide execution details, as well as development in Eclipse, and how to go about developing your own benchmark if you want to, and the management commands that Maven supports. Go back to the pages. And finally, we have a list of the available test cases coming up. So these are all the named test cases that we support right now. We basically go over what each one does, some of the implications of running the test, and important things to consider when running them. And go back to config. Go back to the pages. And finally, we provide the syntax for our config file, which is here. And as you can see, it's really simple. So it's just a tag-based system. So the only tags we really look for are benchmark tests and these three. So any other tags that are included, we pass into the system and they can be used freely.
Okay.
That's it.
That's it.
Any questions?
Okay, thank you very much.